Hello guys, welcome to another Camunda tutorial. In this video, we'll cover another ways of code delegation and execution of external Java code. This time, we'll jump into the technical side of execution listeners and task listeners. Through those mechanisms, you can evaluate expressions during certain events and create generic code delegation mechanisms. Let's get started. To start with, let's quickly model a simple process with one human task. We will use this process to present a simple way to utilize task listener logic. If you choose this task, on the right hand side you can choose Listeners tab, and there let's quickly add one task listener. It is mandatory to choose an event type that will eventually trigger our logic. For this tutorial purposes, let's go for a complete event type. It occurs when the task is completed and just before the task is deleted from the runtime data. We also have to pass the listener type and for instance a class, which will be the delegation class that must be called. It is also possible to use field injection to pass process variables or the execution to the delegation class. Now let's move to our code editor and it's time to create our task listener. The name of the class has to correspond to the value passed in the modeler if you are passing it as a Java class listener type instead of expression or delegate expression. Also, it has to implement a task listener interface. This forces us to implement a notify method that will contain the business logic called upon execution. Let's go for something simple, and this time we will just print something simple on the console with the assignee name. Let's start our application and let's deploy our process. Now from the task list we can launch it, but since there is a human task, the process has stopped and it awaits for completion. Since we chose to launch our listener on task completion, nothing yet appeared on our console. As an assignee, let's complete the task, and now if we go back to the console, we can see that the listener was executed. A task listener is used to execute custom Java logic or an expression upon the occurrence of a certain task-related event. A task listener supports different attributes like event, which is required. That is the type of task event on which the task listener will be invoked, and also attributes like class, expression, or delegate expression to specify the type of business logic called upon the execution. Now let's do something similar with an execution listener. First, let's create a simple process, again with only one human task. On the right hand side, in the Listeners tab, let's go ahead and add a new execution listener. This is pretty similar to what we already did. Let's choose an event type and a Java class which will contain our business logic. In this scenario, we have different event types to choose from. We will choose the start event type, so it will be notified when the task triggers. It is important to note that the values in the event attribute are ignored when a listener is defined on a transition. Similarly to the task listener, our execution listener has to implement a specific interface and it has to override a notified method. Let's print something on the console again, but this time with the event name. When the event occurs, in this case it is start event, the method is called. Now that we have everything in place, let's rerun our application. Once it's up, let's quickly deploy our process from the modeler, and in the task list we can launch it. If we go back to the cockpit, we can see that our process is stopped on the human task just as expected. But since we chose to execute our logic on event start, we can see in the console that the notify method was triggered. Task listeners can only be used with user tasks, since they provide callbacks when the task state changes. Task listener is applicable only for user task types, and execution listener is common for all types like start end events, boundary events, user tasks, service tasks, call activity, embedded sub-process, or even sequence flows. Execution listeners allow you to execute external Java code or evaluate an expression when certain events occur during process execution. The events that can be captured are start and end of a process instance. The process engine has at least one execution semantics. That means a start listener for an activity instance is guaranteed to be invoked at least once. During regular exception-free operation, the behavior is exactly once, which means one invocation per activity instance. However, if the transaction in which the process instance is executed rolls back, the process engine may invoke the listener for a second time. To be on a safe side, your listener implementation should either participate in the engine's transaction or be idempotent. To summarize, both mechanisms have their own life cycles, and one of the biggest differences between them are the event types and the tasks that they are applicable for. Nevertheless, both of them provide unique ways of code delegation, and that is something really worth to be aware of. That's the end of this video. I hope you guys enjoyed it. See you next time.